I welcome all of you to this talk and thank Samagra Shiksha Kerala for inviting me to speak to all of you. Let me introduce myself. My name is Suresh Das and I am currently an emeritus professor at the Indian Institute of Science, Education and Research, Thiruvananthapuram. It is in fact located very close to Thiruvananthapuram in a very beautiful place near Vidura at the foothills of the Ponmudi, and I hope that sometime in the near future some of you will be able to visit this place, this beautiful campus, and see the institute. My field of research is of course chemistry, but what I am going to talk about today has nothing to do with chemistry. Some of you may choose a profession in science and you will have a lot of opportunities to listen to excellent talks in chemistry. So that is not what I intend to do today. And others among you may choose other professions. You may want to become an engineer, you may want to become a doctor or a writer or a fashion designer. Today there are ample opportunities for different kinds of professions. But whatever it is you choose, I hope that it is something that you are very deeply interested in, because that will be necessary if you want to make a success of your chosen profession. But regardless of what profession you choose, it is important that you develop an interest in science and the scientific methodology. And it is important to understand what we mean by science, what is science, where did it all begin, where is it all going, because science is something that affects all lives, regardless of whether it is your profession or not. And not only that, science also teaches us a certain attitude of developing a sense of curiosity. It also teaches us to ask questions. It teaches us that we need not believe something just because some important person has said something or some very large body has said something. It need not be true. We can question it. So this attitude of developing a sense of curiosity and asking questions to understand the world around you is a very important and healthy attitude to develop if we have to develop as a healthy society. And so this is what I would like to do in this talk, to tell you a little bit about the story of science. Of course, science is has a very large legacy, and so you will not be able to cover all aspects of it. But I hope that through this small talk, I will be able to help you to develop a sense of interest and curiosity so that you can read up or follow it up on your own. So of course there are several characteristics that are required if somebody wants to become a scientist. And if I were to pick one important habit that needs to be developed or inculcated, is the habit of reading. The habit of reading. Of course, there are several kinds of books that you can read. There are books on show you how to be a scientist or how to think like a scientist, ask questions like a scientist, do things, discover. So there are some very interesting books that can teach you how to do that or get you interested in how to do that. There are of course many scientists who have had very successful careers, and they like to share their experiences and help young scientists who are entering the field understand how to go about in their profession. And Edward Wilson's book is one such very important book, Letters to a Young Scientist. And it will give you a good idea about how one goes about building a successful career in science. You can also read about the experiences of other scientists, like Venki Ramakrishna's book on the gene machine, which talks about his work and also about his own experiences. And that also helps us to understand the scientific world. But it is not important just to read books related to science. it is also important to read fiction. So reading as a habit is very important if you want to inculcate a scientific temper. So reading fiction, fantasy, science fiction or fantasy or fairy tales is important because these are stories that don't fall within the boundaries of what is possible. So this helps us to develop our sense of imagination, helps us to develop a sense of curiosity, which is very helpful if you want to become a scientist. And that is why it is said, this is a quotation which is attributed to Einstein, which he said, if you want your children to be intelligent, read them fairy tales. And if you want them to be more intelligent, read them more fairy tales. It's not very clear whether he actually said this because he wouldn't have used the word intelligent, but what he means is the importance of reading fairy tales. And as I said, in fairy tales and in fictions and fantasy, you don't have to stick to what is possible. You can think of what is impossible. And that lets your mind free and unfettered to think about things. And that is what science is all about. Because as Einstein said, imagination is more important than knowledge. Knowledge is something that is already in the textbook or what is available, what is written. But imagination is, if you want to bring something out into the future, it is something that does not exist or something that is not understood. That requires imagination. Okay, so that is why this reading, not only books related to science, but related to any kind of reading, biographies, and it's very, very important if you need to help, if you are interested in developing a scientific temper. Okay. So, as I said in this talk, I would like to describe about science and how it all began. So, what is science? Okay, science can be described as an adventure into the unknown, as I said. Because knowledge is everything that is already available in books. But science, when you do science, you are adding new knowledge into what already exists. Something that is not, you discover new knowledge, and that's the pursuit of science. So it's an adventure into the unknown. So you can imagine understanding the universe, as shown in this figure, the Milky Way, and we are a small dot somewhere located close to our sun here, and trying to understand the vastness of the universe. And it need not be just something that great. You can also go to your backyard, and there are mysteries waiting to be unraveled in your backyard. The simple spider or the lizard that you see. There are so many interesting things that you can study about the world that is still unknown by looking into different aspects of this, as I said, our universe and the world around us. Okay. So some of the big questions: when and how did the universe come into being? When and how did molecules form? When and how did these molecules combine together to form life? So these are all big questions which even today are not fully answered, and there are scientists trying to understand it. But we have some idea about these things. And how do we have an idea? It's because of the contributions the scientists have made over several years. Okay. So this is what actually forms physics, chemistry and biology, and the base for all of that science stands on mathematics. Okay. So this is through this understanding of the physics, chemistry and biology and mathematics that we have been able to build up a picture of the universe and the world around us. So let's take physics. Okay. 13.5 billion years ago, matter, energy and space came into being, what is today known as the Big Bang. Okay. At least that's the theory that is most appreciated today and could change in the future. Okay. So 13.5 billion years ago, matter, energy and space came into being, the Big Bang. So the story of fundamental features of the universe That is what we call physics. So you have the Big Bang, immediately after that you have different processes happening till finally you start seeing the formation of atoms, molecules, and then the stars and galaxies and what we have in the universe today. Okay, so understanding all that and the processes and the fundamental principles underlying that is what we call the fundamental features. That is what we call the story of, is what we call physics. The story of these things is what we call physics. Okay? So immediately after the Big Bang, we saw in the previous figure, about 300,000 years after this event, matter and energy merged together to form what is called as atoms, and which combined together to even form even more complex structures called molecules. And those molecules started becoming more and more complex molecules, like I have shown here, some kind of biomolecules. Okay. So the story of atoms, molecules, and their interaction is what we call as chemistry. Now, coming to our planet, about 3.8 billion years ago, on a planet which we now call Earth, certain molecules combined together to form large and intricate structures called organisms, life. Okay? And that life evolved into more and more complex beings till finally led to the formation of humans. And so that process, the story of organisms and their evolution, is what is called biology. Okay? So this is one way of looking at the physics, chemistry and biology that you study, instead of just looking at the laws or principles or names of chemicals. So this is what we are trying to do when we say that we are studying physics, trying to understand the universe. When we say we are studying chemistry, understanding how the molecules that we see makes up the world around us, the life that we see, and how the whole process of evolution occurs. So now let's go into a little bit of philosophy and try and understand when and how did it all begin. Who was the first scientist? Okay. So take a look at this figure. This shows the evolution of the Homo sapiens, which happened about 0.3 to 0.13 million years ago. Okay. Before that, you had all these other species, and you can look at something like this is model 1, model 2, model 3, model 4, still trying to perfect itself. Okay, still we have the current model of the human, Homo sapiens we call it. Okay, and you look at the brain. So each of these new models had a bit improved computer. So brain, of course, is the computer. So the computer that is installed in each of these improved models kept improving. Okay, so till we have the current computer. Okay, the structure of it. I am not going into the details of all this, but that is highly evolved and highly complex computer. So something happened between this time, and that was the evolution of language. And to me, that portion, that time, is probably where science began, or the birth of science started to take place. Now, why do I say that? What should the evolution of language have to do with the evolution of science? Okay? Because we know that animals can communicate. Insects communicate. Ants can tell other ants where to go and find the honey or sugar. And so can the insects, like bees can tell other bees where to locate the flower with the honey. So they can communicate. And there is an example, there is an example in animals, monkeys. When monkeys, a group of monkeys is attacked by a lion, so they start shouting with something that can be loosely translated as "Look, lion!" And immediately all the monkeys will climb up into the tree. Okay, so they understood that. All of them understood that. If on the other hand they are attacked by a big eagle, they make sound of noise which can be loosely translated as "Look, eagle!" And immediately all the monkeys start to look up. So they have a language. And if you record those, for example, "Look, lion," if you record that sound and play it immediately and play it loudly, immediately all the monkeys will go up and climb the tree. So that means they have some rudimentary aspects of language. So why is it that the human language was so special, and what is the role that human language played in evolution of science? Okay. So when you look at communication between insects and also of animals, they can only describe what exists. Okay. For example, I will tell you, many of you, your teachers would have asked you what happened to your homework. And some of you will tell what happened, but some of you may actually tell something that never really happened. So that is the ability of language to describe things that have not happened or things that we imagine. That is only possible among humans. Okay. So the ability to tell stories and translate your imagination to another person, okay, that was born with the evolution of language, human language. So unlike animals which describe only that which is, we as human beings could describe things that are either present or not, or something we just totally imagined. So that is like the art of telling stories. Okay. So you can imagine our very first scientist sitting and looking around in his world, and the earth would have been very active. There would have been a lot of volcanoes, thunder and lightning, floods, okay, and there is no light to disturb the sky, so the beautiful spectacle of the night sky. So it's enough for him to wonder about and what is behind all this. And none of this is something that he understands or controls. So basically this is a person who is completely at the mercy of nature, and this is not acceptable to humans, because then, we are opposed to chaos. There has to be something to control something. So that is when they wondered that somebody has to be in charge. Who is in charge? Okay? And this is where probably the concept of God and gods came, because somebody had to be controlling all this. It cannot just be automatic and chaotic. And so if you knew that some gods were controlling them, then if you were able to pacify those gods, then you would be safe. So this is how probably the evolution of thinking of God came about, and the birth of religions, myths and stories. So in a way, they were trying to explain, using these kinds of stories, what they were seeing around them. Okay? So they were almost like what we say modern scientists, but they didn't have anything to go by. They couldn't measure anything. They didn't have nothing to explain things with. So they started making up stories. So different mythologies in different regions, whether you have Roman mythology, Greek mythology, Egyptian mythology, Indian mythology, and so many kinds of stories came about. The concept of God and gods came about. Okay, so let me just take one such myth. That's called the myth of the Ouroboros. It's a very interesting myth. Okay, and I will tell you how that was born. So because as the early human being he watched that everything had a pattern. Everything was cyclical. So birth was followed by death, people being born, people dying. Day was followed by night, and night was followed by day. The stars had a particular pattern which changed over the span of the year and then repeated itself. So that was also cyclical. Seasons were also cyclical. You had summer, autumn, winter, spring, and that continued. Tides came, tides went. Phases of the moon also was cyclical. So they could see something. They were observing. And so that from that was born the myth of the Ouroboros. Okay? And what is that? You can see that this is an Egyptian depiction of this myth. And you can see two circles here. Okay? What these circles are is actually snake eating its own tail. So the snake grows by eating itself. So the tail is being eaten, and as it is dying, it is growing. And you can see that there are two such circles in here. So this is the Egyptian mythology. The same thing exists. in Greece. You can see this is a drawing from ancient Greece. Snake eating the tail. And also in Norse mythology, that is Norway, the Scandinavian countries. Okay. They think that their universe is surrounded by a snake and held together by a snake, which has the tail in its mouth. Okay. And if you look at our own Indian mythology, ancient mythology, where initially they described the earth as being resting on elephants, which rested on a giant turtle, which rested on the snake. So you can see that diverse cultures had these kind of stories and myths that were built around. Basically, in a way, they were trying to explain what is eternity and infinity. Of course, they had nothing to go by. So that is, you can see, if you take every mythology, every story, whether they talk about, in the Greek mythology, they talk about Apollo carrying the chariot, carrying the sun in a chariot from the east to the west. So all of these were somehow stories built to try and explain how there was some kind of rules, general rules by which we could somehow or some way explain the world around us. Okay? So they had only this limited means of experimentation, and they had to rely on a range of unverifiable assumptions. Okay? So therefore you can see that how the two forms would have developed. So science was also trying to discover laws that govern the natural phenomenon that they see around us, but that was based on a system of gaining knowledge of nature through repeated observations and experimentation. At the same time, religion also was trying to understand, or religious myths also tried to understand the things, taking for granted that most of it was controlled by some kind of God who acted in an orderly manner to make sure that the rules of nature are followed. But of course, this was a system that one could not question, and the verification was not something that was required. So as human knowledge progressed, you can see that the need for unverifiable assumptions to answer such questions slowly came down, and eventually science and religion separated, and what led to what we today call as modern science. And I will come to that in the later slides. Okay? Where we believe that if we have to make a statement, there has to be a basis for that statement, at least in science. So when we ask questions like, how did the universe begin? How did atoms and molecules form? How did life on Earth begin? We have questions today, we have answers today from science. There need not be some explanation outside of science. Of course, there is a long way to go, but that's also understood. Okay? So, and even many of the hypotheses that we have in science, it welcomes questioning. So, and we keep questioning these premises, try to improve the hypothesis, try to improve our understanding. This is opposed to the way religion works, where you are required to have an unquestioning belief in some sacred text. So this is the basic difference. Okay? So in science, there is no problem if we prove something is wrong. In fact, that is welcome. If we have conclusive proof that something that we were thinking about in some way happens to be wrong, that is welcome if sufficient proof is provided and a new theory is developed, and that brings us closer to what is a reality. And so, little by little, we try to move closer and closer to understanding the universe and the world around us. Okay? So, continuing on with this, the evolution of science, how did modern science evolve? Actually, if you look at many books and you try to find out how science began, and you look for the origins of science, you will see these kind of statements. The first people to try and develop the theory behind their observation were Greeks. Pythagoras developed a mathematical view of the world. Aristotle and Plato, they developed logical methods for examining the world around them. But how far is this true? Okay? Is this that the understanding of evolution of modern science actually took place only with the Greek civilization. What about India? What about Mesopotamia? What about Egypt? What about Arabia, China, the Aztecs, Incas? Okay. So I had shown you earlier that all the basics of underlying basics of modern science is mathematics and numbers, which of course is dependent on numbers. And when we see that even early Chinese civilization, as far back as 200 BC to 200 AD, had developed a sophisticated way of counting, and with the base of 10, and you can see they used symbols of bamboo sticks, 1, 2, 3, 4 and 5, and when it is 5 it is shown as a horizontal line, and that horizontal line plus 1 is 6, and horizontal line plus 4 is 9, and 2 horizontal lines would be 10, and so on. So that is how they developed their numbering system. And whereas in the Mayan civilization of Central America, even 500 AD, they had also developed a numbering system. In fact, they had also developed the idea of a zero, and it used as the main base 20 and auxiliary base 5, and the numerals were pictographs. Okay, instead of bamboo sticks, they used lines like this and pebbles, and otherwise they were very similar to the Chinese. But something very spectacular happened in India, and that is the Indian number system. You can see it was first appeared in 300 BC to 100 AD, and the numerals 1 to 9 were evolved, and they were depicted by certain very characteristic pictures. And so when you look at 0 is said to be discovered in India somewhere around 3 to 2 BC, and the word 0 actually comes from an Italian word which was formed from the Arabic sifr, meaning empty, which of course was a translation of the Indian word shunya. So much of these Indian numbers were introduced to the Western world by the Arabs, who were highly appreciative of the complicated numbering system that was developed in India. And today you can see the Latin numbering system what we use, also the Arabic number system, has its roots in this number system and this concept of 0 that was developed in India. And of course there were many other great scientists. You can see here for 1,000 years before Copernicus. Here we had Aryabhatta, who was trying to understand the diameter of the Earth and the Moon, understanding that there were spheres. That proposal that the Earth rotated on its axis to explain the daily motions of the fixed stars. So you can see how advanced the thought was. Solutions to quadratic equation, defining trigonometric functions, the importance of 0, and determining the value of pi. All that was happening in India. Even within our own state in Kerala, you can see there was what is known as the Madhava School of Mathematics, and J.S. Deva was working on the infinite series and the rudiments of calculus much before me. Okay? And so this is something that I took from the website of St. Andrews College in UK, and you can see, the history that this timeline shows on the development of mathematics. So as far as 800 BC, we had Indian mathematicians trying to understand the fundamental aspects of mathematics, and so when we look at Pythagoras, you can see it was much later. So when we say that there was nothing before the Greek civilization, you realize that is not really correct. So different civilizations. Chinese had also contributed to mathematics. Here what I've shown you is the Indian mathematicians, these red names, Baudhyayana, Manava, Apastamba and Panini and so on. So many great Indian mathematicians have contributed to the development of mathematics. And we also know about Shushruta, the ancient Indian physician who was and developed concept of surgery, plastic surgery even, so this was also known, and so these are just few examples I wanted to show that how science flourished in other civilizations. In India, this is an example. At the same time, a little later there was also a very golden period of science in Arabian countries, Arab scientists, They worked in many countries, including India, Baghdad, Afghanistan, Cairo, Cordoba, and all of these actually the Arab mathematicians who were highly appreciative of Indian numbering system and Indian mathematics. They combined the Indian arithmetic and Greek geometry to what is developed what is today known as algebra. It's an Arabic word, from an Arab name of an Arab scientist that the word algebra comes. And Arab physicians also combined Greek and Roman and Indian medicine and wrote medical encyclopedias, which were used as standard textbook by the Europeans. Okay, so one of the greatest of these Arab scientists was Ibn Sina. In West he is known as Avicenna, and he was a Persian polymath. He was one of the considered one of the greatest thinkers of that time. There is a significant physicians, astronomers, thinkers, and writers. So he was one of the most famous of all of them, and today recorded as the most influential philosopher of modern era. So it's interesting that you see that you have all of this science that developed in, I told you about China, India, Arabia, many other countries, and also Egypt, had very highly developed science in prehistoric times. But then, why is it that modern science, that this trend did not continue? It is, when you look at modern science, most of it was born in Europe, specifically in England. And why did that happen? And that is something very interesting for us to think about. Okay? As I said, another great scientist, before I go to that, I'll just describe another great scientist from Arabia was Jabir ibn Hayyan, who was an alchemist, who used to take fruits and try to understand what components of the fruits were. They used to distill, do an analysis, trying to really understand the world around us through experimentation. And they found out that fruits are made up of different combination of different things, contain water, alcohol, acetic acid, and sugar, and so on. Okay. So now coming back to the question I asked, when all this was happening, of course, Europe was in the Dark Ages. So when Europe was in the Dark Ages, why is it that among all the countries that the modern science actually, the way we know and do science today, was born in Europe and not in many of these other countries which had such a large history much before that of Europe of doing very good science. Okay, so I think to understand that, you have to understand that there was a large, the reason much of science didn't happen in early Europe was it was considered to be anti-religion. And I give the example of Giordano Bruno, who was from 1548 to 1600. He was an Italian priest, a philosopher, and he used to refer to many of these Arab books, like the books written by Avicenna, and say that this is something that we need to study and understand. But that was taken as something to be anti-religion, and in fact he was killed. He was one of the earliest martyrs for science, and he was finally burnt at the stake. And this was, you can see, this was in Italy, and when this was happening, Galileo was a young man, and so he would have seen what happened to Giordano Bruno. So when they came to him and he had all his theories about Earth not being the center of the universe, and that was contested, he was ready to recant because he didn't want to the same thing that was done to Giordano Bruno to be done to him. And he said that any country that badly requires heroes doesn't deserve them. So he said, I'm going to recant. I'm not going to try and be any hero like Giordano Bruno was. So if the country wants to protect the scientists, the country should protect, not the scientist himself should not have to be a martyr and a hero. So he readily recanted, and of course he died in house arrest. So this was the atmosphere in Europe at that time. So therefore many felt that this had to change. And so because of that, people like Francis Bacon was a philosopher and statesman, and he felt that in order to understand nature, he said it is very, very important to meticulously clean the mind of all anticipations. That is, expect something and look out for that. So you should not have, when you go approach the scientific methodology, should not have any anticipation of what the result should be. We are going out there to try and understand the universe. and understand the systems for what it is. So if you have prejudices, or if you have anticipated a certain kind of, or you want some kind of result, then that prevents you from looking at things with clarity. And of course, as he says, we cannot have any idols. So one has to have an extremely questioning mind. So this was one of the earliest thoughts, and that immediately close to that was Robert Boyle, and he did something, because what he also recognized is restriction that the religions were imposing on the progress of understanding nature and science, and that they felt that there had to be a place where people of like-minded people could exchange ideas and talk about science without those kind of restrictions. And he started what is known as the Invisible College in 1660. And then that is what eventually became the Royal Society, what we know today as the Royal Society of UK. So if you try to understand why it was that in modern science, the way it happened, took birth in England and in Europe, and specifically in England, was that these pioneers made a clear cut between scientific thinking and religious thinking. Now, I'm not saying that religion is not important, it has its other roles in society, but when it comes to science, when one has to work with a scientific methodology, one cannot mix the two. And so that is where the motto today, even today, the motto of the Royal Society is Nullius in Verba, that take nobody's word for it. Okay? Main principle of science is experiment is the best test. You have to prove something that you say using an experimental technique or measurement or something. Okay? And the strength of science is that it is provisional, that there is nothing permanent about it. You prove, I discover something and somebody else comes and says that this is wrong, and you prove it conclusively, it has to be accepted. So there has to be an open-mindedness and a capacity for doubt and uncertainty. So this will be seen as weakness in many other kinds of thinking, but this is the strength of science. So, and that is when around that time was a word first coined, the scientist word was first coined in 1833. Till that time, scientists were referred to as philosophers, natural philosophers, and other things. The word scientist was then coined by William Buell in 1833. So you can see interestingly why in many other societies which had much more advanced scientific knowledge did not develop modern science, because this wasn't required. You couldn't mix up religion and science and continue to progress in the way that happened in Europe at that time. And subsequently, people like Antoine Lavoisier were able to carry forward the work of what was done by the alchemists in Arabia, where they had first found out that most of the matter is made up of small chemicals. Then even in France, Lavoisier was able to take these molecules and then see that they were made up of separate components like the elements, hydrogen and oxygen, and that subsequently led to the understanding of what we know as modern science today. Okay, so this is the timeline, and you can see. So of course there was a major contribution to all this, and subsequently, and many of these people have contributed today to, and this gives you one glimpse the way science evolved. Okay? Today, of course, we know about the great scientists. These are some of these names. I'm sure you recognize all of them. There have been many great Indian scientists: C.V. Raman, S.N. Bose, N. Ramachandran, Venki Ramakrishnan. Okay, so these are what we call as the giants of science. And very often, many scientists say that we stand on the shoulders of such giants. That when we do science, we are able to do it because we are able to stand on the shoulders of such giants. But when we talk about physics, what we know of physics today, what we know about chemistry and biology today, is it all because of the work of the giants? I think it's not fair to say that, because several thousands of scientists have worked and contributed to that. And sometimes it is not also unfair to say that many of these giants stand on the collective shoulders of these scientists who have contributed in their own way to understanding the world around us. So this is, in a short way, I have tried to give you how science progresses, but what is the future? Where this is all take us, of course, is, if you can imagine it, it can happen. There is no limit. Okay? And if I were to just give you a few quick examples: artificial intelligence, robotics, space travel, self-driving vehicles, hydrogen fuel from water, car batteries which charge in 10 minutes, floating farms, living hearts grown in the body, endless. One cannot even begin to imagine. Imagine that you are sitting in the beginning of the 20th century, where where the aeroplane was not even known, and today we have vehicles going all the way up to Mars. Okay. So one cannot imagine what is going to happen in the next 50 years, 100 years. And all that is going to happen because every technology that you see today is possible because of a fundamental understanding of science. And that happens hand in hand. Better understanding of science, better materials, better ways of doing things, and science progresses in better technologies. And unimaginable, because growth is going to be exponential. And who is going to do all that? Because science is a limitless ladder. So who will write the story of the science of the future? I hope some of you. Okay, and I hope with this I have talked and you have inculcated some idea about how the whole process of science evolved, and I hope that you will be able to, as I said, the story is endless. It has to be continue to be written in ways that none of us can ever imagine and see in our lifetimes at least. And I hope that some of the major contributions in the future will come from a few among you, and I wish you all the best. So with this I will stop my talk and thank you.